Hello. Today we're going to be doing option number 5, which is an interactive smartboard lesson. And this interactive smartboard is going to cover mainly lesson 2 of your foundation worksheet. And you want to have this Word document out in front of you as we do the interactives so that you can answer the questions as we go. Now first you want to make sure to write your name and your partner's name, period and date up in the right hand corner. So if you do lose this, you can easily identify it. All right? So first thing I'm going to have you do is, if you haven't already, go to this link. And watch it open up. All right? So today we're going to talk about radiation, conduction, and convection, which is basically heat transfer. Now, if you look at the left-hand side of the screen, it's going to say, in our environment, heat transfer always moves from the hotter object to the colder object. Heat transfers to and through some materials better than others. Click on the convection, conduction, and radiation tabs to learn more about each method of heat transfer. All right, so now we're going to go right into radiation. And remember, heat transfers to and through some materials better than others, and it also transfers in many different ways. All right, heat transfer through radiation. And you can follow with me on this left-hand side of the screen. Radiation is the transfer of energy along electromagnetic waves like light waves and radio waves. A good example of this would be the sun. When a wave comes into contact with an object, the energy is transferred to the object in the form of heat. That's why things feel hot when they're in the sun a lot. Of the 3 methods of heat transfer, radiation is the only one that can travel through empty space. This is how the sun's heat can transfer to Earth from millions of miles away. All right? And before we go on, I want you to go back to your Word document and fill in 1 to 2 sentences what you just learned about radiation. Make sure you hit pause on the video so that you don't miss anything. So go ahead and hit pause and write down 1 to 2 sentences. All right. Now that you have your 1 to 2 sentences about radiation that you learned we're going to click the tab that says Add Sunlight. So I add in sunlight, and as you can see, electromagnetic waves from the sun go down on the house, and the temperature inside the house is shown right here. All right? And you can now pause again and answer the second question: what happens to the temperature of the house? Right there. All right, now that you can see what happened to the temperature of the house, we're going to go and hit the examples tab, which is right here. And now it's going to give some examples of radiation. One example is campfires. Another is microwave ovens, light bulbs, and the human body. A campfire emits light waves, which in turn transfer heat to objects by radiation. In addition, the campfire transfers heat to the surrounding air by convection. If you want to, you can go ahead and pause this and read the rest of the examples. And then after you read those examples, make sure you write down the specific examples. So the first example was campfire. So right here, you can write campfire. Go ahead and fill in the other 3 examples. And then what I want you to do is write your own example right here. So go ahead and pause it and write your own examples. All right, now that you have that done for radiation, we're going to go on and we're going to hit the animation tab and go back on to conduction. All right? Conduction is another form of heat transfer. Conduction is the transfer of heat between objects or substances that are in direct contact with each other. Heat can make atoms vibrate or set electrons in motion. And like we know, all things are made of atoms, and those atoms have electrons, and what the heat does, it sets those electrons in motion. The heat is transferred when the vibration or motion communicates to neighboring atoms. Conduction works well in solids because the atoms are close together. It works poorly in liquids and gases because the atoms are further apart. And that's why the different states of matter make sense now in determining heat. All right? And now what I want you to do is go back to the Word document. Right here. And under heat transfer through conduction, I want you to write 1 to 2 sentences about what you just learned about conduction as a transfer of heat. Right here. So you can go ahead, pause the video, and write that down now. All right, and now we're going to go back to this animation right here. And as you can see, conduction is through two objects touching each other. So the pot and the burner are touching each other. Now let's see what happens when we light the burner. Having some technical difficulties. All right, now that the technical difficulties are over, we can light the burner. Light her up. So as the burner is lighting, make sure you know what's going on. And he couldn't touch it with his hand. All right? So now that you just saw what happens, you can replay it if you wish, or you can just go right to this, back to the Word document, and answer what happens to the pot in the interactive. So then you can have these two things answered. All right? You can pause the video and write that down now. All right. And now that you wrote those answers down, we can go to the examples. All right? Copper, steel, and silver, and iron. Metals are excellent conductors. If you have a metal spoon in a hot soup, the soup will soon be very hot too. When you touch cool metal objects, they feel even colder because they are conducting the heat away from your hand. So like when you go into a car and you feel a metal seat belt and it feels cool, that's heating through conduction. Air. Gases are not good conductors because the atoms are farther apart. Materials that are filled with air pockets like styrofoam prevent heat transfer and make good insulators. If you want to, you can go ahead and read that again. And then make sure to answer this question down here. What is better for conducting heat, gases or metals? Also, I want you to write down an example of a good conductor and a bad conductor that are not listed. All right? So you can go ahead and pause the video now and write those down. All right. So now that we have radiation conduction done, we're going to go to the heat transfer of convection. All right? Convection is the transfer of heat by movement through a medium like air or liquid. It is the primary method of heat transfer through gases and liquids. As a gas or liquid medium is heated, it warms, expands, and rises because it is less dense. When the medium cools, it becomes denser and falls. As the medium warms and rises or cools and falls, it creates a convection current. All right? So if you want to, you can go ahead and read that again, or you can go down to heat transfer through convection and answer this question right here, where I want you to write down 1 to 2 sentences about what it's saying about convection as a transfer of heat. You can go ahead and pause the video now and answer that. All right, now that you've answered what you've learned about convection, we're going to go light up the stove. So it's lit right now. And as you can see, the warm air is rising and becoming less dense, and then it's cooling and becoming more dense and falling. So as you can see that convection current that's going on right now. All right? And what you see, I want you to go ahead and write down what is happening in the interactive with the arrows. I kind of explained it a little bit, but you go ahead and you can write down what you think. Go ahead and pause the video now and write that down. All right? Now that you wrote that down, what you learned about convection, we're going to go and look at some examples of convection. So water boiling in a pan is an example. If you observe a pan of boiling pasta, you will see the pasta rise and fall with a convection current in the boiling water. So next time you watch mac and cheese being cooked, you can see the noodles rise as the you pour them in the boiling water. All right? So now I want you to go back to your Word document and make sure to write down those examples in bold that were listed right here. So you can put boiling water. And then I want you to write down the other two examples. And then you can go ahead and write down your own example. Okay? So you can go ahead and pause the video now and fill those three things in. Make sure you go back to the interactive and read the rest of these things. Go ahead and pause the video now. All right, now that you have everything answered on your Word document about heat transfer, we're going to go on to the next interactive about specific heat. All right, and like it says up here, these questions will be using this following website. If you're not already there, you can go ahead and click. I'm going to go ahead and click on the link, and it's going to bring up the interactive. It'll pop up. Go ahead and click OK. All right. And before we begin, specific heat simulates an experiment that demonstrates the different heat capacities of land and water. As the simulation progresses, pay close attention to the graphs showing how the temperature of each substance changes over time. Okay? So we're going to hit proceed. And then, as you can see here, we got two heat lamps. And on the left-hand side in the blue, we have water. And on the right-hand side, we have soil. Okay? And I want you to pay very close attention to the temperature and time graph in the background. So we're going to go ahead and hit play, pause, play, and it's going to turn on those heat lamps. All right? So one thing I want you to focus on is what's happening to those lines in the background as those heat's going up. Okay? So I want you to pause it and pause the video and go to the Word document and answer this question. What is happening to the line on the graph as the time and heat are increasing? Go ahead and pause the video now and answer that. All right, and also you can answer why you think that's happening. So focus on which line is rising faster, the brown or the blue. All right. And now the main definition that you want to think of about specific heat in the definition of specific heat is the amount of heat needed to change the temperature of 1 kilogram of a substance by 1 degree Celsius. Okay? So as you can see with this line graph, the water has a much higher specific heat than the land because it's taking a lot longer and a lot more energy to heat this up. Okay? So it's taking a lot longer to heat the water up. It's a lot lower than the soil line. Okay? So as you can see, water has a much higher specific heat than soil. Okay? So I want you to go to your Word document and why do you think this is rising faster? Base your answer on what you are hearing from the video. Okay? Go ahead and pause the video now and you can answer that. Now that you have that answered, we're going to look at what happens when we turn the heat lamps off and the soil and water are cooling. So I'm going to turn it back on. And as you can see, the brown line is decreasing a lot faster than the blue line. And this is specific heat in action right now. Since the water is such higher specific heat, it will stay to that level a lot longer than the soil will. This is why when you go out to a lake at night, you can see steam going off of it because the lake's a lot warmer than the air. Or in the summertime, during the day, you can hop into the water and it feels a lot colder than the air because it maintains that same temperature for a long time. So I hope you learned a little bit more about specific heat, and I want you to go ahead and answer If you haven't answered that, go ahead and answer that, and I want you to answer the heat decreasing, which is the same questions but opposite for when it's decreasing, or for when the heat's decreasing. Okay? So you can go ahead and pause the video and answer those. Now, for the last part, it's a reflection piece. So I want you in 3 to 4 sentences, write what you learned about each of these 2 videos. So think about heat transfer with conduction, convection, and radiation, and think about specific heat. Thank you very much.